So how do we approach an application problem involving a percent? I suppose the first question we should ask is, what exactly do I mean by an application problem? Now, in math class, for the most part, we know what application means, right? Application means word problem, right? And math teachers just say application because we know if we say word problem, you're going to say go away. No, that's not the point here, though, is it? The point here is to be able to use the idea of percents in real-life applications, in situations where we actually want to describe something using a percent. That is, we want to describe some portion relative to the base, or understand someone else's description. So don't think application equals word problem. Instead, think application means, how am I going to use this? Not where am I going to use this. You will find places to use it as you go along. But how? When it becomes useful, how will you use it? Of course, this being a class, we have to present these applications to you somehow. And the form in which we're going to present them is word problems. But this idea means that our approach to word problems can't consist of just very carefully parsing the phrasing. It has to consist of the set of questions that we ask in order to figure out how the technique applies. That way, we'll be able to take the same ideas to situations that we encounter in real life. So, when we encounter a percent application, there are two very straightforward questions we need to ask. The very first question we should always ask whenever we see a percent is, percent of what? That is, what is the base? And what does the base do for us? Well, the base is what we're using as our reference. The second question we need to ask is, what does this percent actually represent? That is, what is the portion? And really specifically, the thing that we're looking for is, what is this story actually about? Notice, these are both questions whose answers are not numbers. So when we say, what is the base, we're looking for all high school students, not 2,387 if there are 2,387 high school students. We're looking for the quantities that the numbers will describe. Often when we encounter a percent story in real life, the numbers aren't right there. We have to go out and look up. How many high school students are there in the United States? If we want to figure out what number the base is. But if the percent is presented in any meaningful way, we will be able to get out of the story what the base ought to be. Sometimes we already know what the base is because it's clear from our context. Sometimes it takes a little bit more digging, and sometimes we're expected to have something in our background knowledge that tells us what the base ought to be. Let's see a simple example where everything is right there in the story. Suppose we know that at a certain university, 61% of incoming freshmen will graduate in 4 years. If there are 2,165 incoming freshmen in fall 2015, how many will graduate in spring 2019, that is, 4 years later? So we need to answer those two important questions. We need to decide what is the base, that is, what is this a percent of, and what is the portion, that is, what does this percent represent? In this story, we're told 61% of incoming freshmen will graduate. So we have this phrase, percent of. That tells us that we're going to be told what the base is. Percent of what? Incoming freshmen. So the base is going to be incoming freshmen. And what does this story tell us about 61% of incoming freshmen? Well, it says that 61% of incoming freshmen will graduate in 4 years. Some incoming freshmen, and out of every 100, 61 will graduate in 4 years. So if we wanted to, we could rephrase the sentence about the percent. 61% of incoming freshmen will graduate in 4 years means for every 100 incoming freshmen, 61 will graduate in 4 years. So now that we understand what this percent is saying to us, we can think about this specific question about it. So this says there are 2,165 incoming freshmen in fall 2015. And we want to know how many will graduate in spring 2019, which is 4 years later. That is, of the 2,165 incoming freshmen, how many will graduate in 4 years? Now we're ready to assign numbers to the base and the portion. Okay. So there are, in fact, 2,165 incoming freshmen, and an unknown number of those that we want to find out will graduate in 4 years. So we know what the base is. We're looking for the portion. We know the percentage. We're ready to set up a percent proportion. Notice all this work we did before we actually wrote any math. Before we could write down any math, we had to understand what the question actually was. So, our percent proportion, our percentage was 61. That was told to us in the problem. That's always going to be over 100. We decided we're looking for the portion, and the base is 2,165. This is a proportion. We can go ahead and cross multiply. So let's do this multiplication. 1 times 5 is 5. 1 times 6 is 6. 1, 2. That one was easy. 6 times 5 is 30. 36, 37, 38, 39. 6, 7, 8, 9. 12. 5, 6, 10, 12, 3, 1. So x times 100 is 132,065. So that means that x is 132,065 divided by 100. Dividing by 100 is easy, right? This is going to give us a fraction with denominator 100. We'll want 2 digits after the decimal point in our answer. 132,065, decimal point goes here. 1,320.65. It doesn't make sense for 0.65 of a student to graduate, does it? So we should round our answer to the nearest whole student. And our answer is going to be about 1,321 will graduate. Let me give you one of these to try. Suppose that we know that 54% of the students in Jesse's graduating class are women. If there are 135 women in the class, how many students are there altogether? So, first answer the questions, what is the base and what is the portion in words. Then, figure out the answer to the question. Pause the video and try this now. All right. Well, okay, so what is the base answers the question, percent of what? And here we're told explicitly, percent of the students. What students? The students in Jesse's graduating class. 54% of the students in Jesse's graduating class. So the base is the students in Jesse's graduating class. And I'm going to shorten that to students in Jesse's class, because I don't want to write all that again. And then the portion is the answer to the question, what is this percent actually telling us about? And it's telling us that out of Jesse's graduating class, some of them are women. 54% of them are women. The portion is the ones that are women. So we could rephrase this sentence as, for every 100 students in Jesse's class, 54 of them are women. That seems like a reasonable sounding sort of sentence. And now we're ready to answer the question. Let's put numbers to these things now. So the story says there are 135 women in the class. So the ones that are women, they number 135. And the question is, how many students are there altogether? So how many students are there in the whole class? What we're looking for is the base. Now we're ready to set up a percent proportion. Before we answered these questions, we were not ready for that. So 54% is what we're given. So the percentage is 54, and that's out of 100. The 135 we decided was the portion, and what we're looking for is the base. This is actually a proportion. Cross-multiplying is what we want. We'll have 135 times 100 is x times 54. 135 times 100, that's easy. That's write it down first, put in the comma, then say its name, 13,500. So my x is going to be 13,500 divided by 54. Now it's time to do that division. 54 doesn't go into 1, it doesn't go into 13. It does go into 135, I think twice. Yeah, 3 is going to be too big. Can't do that, gotta borrow. 15 minus 8 is 7. 2 minus 0 is 2. 1 minus 1 is 0. Bring down another 0. 54 goes into 270, I think 5 times. 20, 25, 26, 27. Oh yeah, 5 exactly. I'm not done though, right? I have to do something with this 0. 54 goes into 0. No times. I get x equals 250. What does that tell us? There are 250 students in Jesse's class.